Robin, can you turn the light on over there?
Just one little suggestion from Joe. This electromagnetic tether gives you an opportunity to install satellites in sun sequence orbits at designer altitudes, and that may be of interest to some customers.
Yeah. The whole challenge is that people don't take electrodynamic tether seriously. Okay, and even though PNG works, and
after hearing your presentation, you don't take it seriously?
No. They asked to take me seriously until I had 4 successful flights, and then they got interested in other stuff.
Okay, Professor Sheffer-Roach, I have a suggestion that you concentrate on materials that can be produced on the moon. You said that the titanium-boron combination is not the best means of producing these products. Boron, of course, is something that would have to be brought to the moon. It's a dispersed element, very rare element on the moon. So I think you're right in steering away from that. I do wonder, however, whether titanium can be used in a thermite-type reaction using lunar material. You have the magnesium, the aluminum thermites, but what about titanium? Can that be made to work?
Titanium?
Yes.
I would say no.
Hmm.
Because titanium, I don't think that titanium will reduce any of these.
Yeah, I don't have the heats of combustion, the heats of formation with me either, but
let's see what theoretically reduces, then probably the combustion temperature will be too low. We can check actually, so it's easy to check with thermodynamic calculation, but I think titanium is not sufficiently effective.
yes. Okay, but any of these materials that you might be using, aluminum, elemental magnesium, and even elemental titanium, there have been elaborate studies of how to separate, purify, and produce large quantities of these elements on the moon, done by Bob Waldman some years ago, 20 years ago. And those studies are extremely useful for providing guidelines as to what native lunar materials can be made available for these uses.
Yes. Also, there is one option to transport aluminum that they are going to collect as a low Earth orbit to the moon.
Yes.
So it's actually easier as compared with transportation.
Or your step stages from anywhere.
Yes, because if you want to transport something to the moon, the largest problem is to transport from Earth's surface to the orbit. Yes.
There's still the energy cost of landing it safely.
We've got 4 minutes and 4 questions.
Just a couple of comments and suggestions for the heavy data tethers. I'm not sure what sort of tip velocities you're talking about.
It's tens of meters a second. The reinforcement, the peak loads are not high. It's not intended so much to throw stuff as to just get it out normal to the field. But if we add reinforcement, we can throw stuff harder, and then we can target the reentry of larger objects. But
if you're just trying to re-enter stuff, that would reduce the solar power that you need, because you could just simply fling things backwards and that would raise the tether.
yeah, that's planned to be done, but the question of how much reinforcement we use slows us down. There's an optimization.
Cost, yeah.
You have to have a specific mission scenario, and then you optimize for that and build a vehicle for that. But then, fortunately, all that involves is changing like how far away the same solar arrays are spaced to change the mass ratio between this and solar arrays. It's an easy optimization is done with the scissors.
You do it. And a question for the sintering, the solar sintering. You're talking about doing multiple passes and doing multiple layers. You consider the possibility of sifting dust down onto the sintering area while you're sintering. So it's a continuous process, and you don't get multiple layers of delaminate.
Yeah, we tried that in a very rudimentary way, and it does work. We tried that in a very rudimentary way, and it does work. And I think that is a very desirable way. In the case of the field, then we just were not able to implement it.
More experiments needed.
Yes.
Next question.
This is one about building something, centering problem in there. Something that came up there's so much of this stuff that gets lost over the years, and something that came up years and years ago was a mechanism for making something very much like asphalt on the moon, was to vapor deposit aluminum on the regolith. And then just because it's fresh and, non-oxidized surface, the vacuum thing, it sticks. And so you put enough aluminum on it to make it sticky enough as if it was almost like tar, and then you just compress it. You have to do this in a vacuum, and it'd be harder than heck to do it at a decent vacuum on Earth and make it work. But if you vapor deposit aluminum on gravel, you can make the gravel stick like crazy. There's all sorts of stuff that's been lost. I doubt, is there anybody here who's ever heard of transportation?
There's a
Okay, one person, two people?
raise your hand.
Three. See, it's an idea of, much of this stuff is getting lost, and that's pretty bad. Transportation is simply a matter of, if you bring stuff down on the moon, just dig a big, heavy metal line hole in the moon with a fast-acting door across the top of it. And you just don't land it at all fire, you just crash it right through a cutter bar in the middle of it, and slam the door real quick, and then pump it out, something like ammonia or liquid oxygen.
Next question.
I was wondering, I was under the impression that electrodynamic tethers would have difficulty operating at high altitudes because it requires...
Yeah, they run out of steam. And the question is, electrodynamic tethers are so much better than anything else in low Earth orbit. What's the altitude beyond which they're not the best solution? And we don't know that yet. I think it's going to be very far below GEO, but I don't know it. Okay, but the key thing is you start at 600 to 800 kilometers, clear that out, and then go up to 1,000, then go to 1,200, then 1,400, because you can remove more stuff in less time and also clear out the region you would be running through if you clean out from the bottom up. So it's not even clean out all the way up first. First you start out with 600 to 800 kilometers. Okay.
All right, we have time for one last question.
David Rose, Physics Conversion. So speaking of altitudes, given the Russian fondness for Molniya and tundra orbits, is there a degree problem there, or is there a harvesting resource?
I don't, the mass in orbits of high eccentricity between LEO and GEO, like GTO, low inclination, and Molniya orbits, the total mass is substantial, but the volume involved is so much larger that the real issue is first clean up LEO. It's like the economy stupid. It's LEO first, and then we'll stop and take a breath and have a cup of coffee and decide what to tackle next. Okay? That cup of coffee is 10 years away.
All right, let's give everyone a nice hand.